I'm really excited for this next talk. Tomasz is a core developer at Parity Technologies, has been around since the very start. Was right by Gav's side, building out the Parity Ethereum client from day one. So he's got a deep well of knowledge about all things blockchain, and he's the go-to guy now on bridges and oracles at Parity Technologies. So without further ado, I'll let you take it away.
Thank you, Peter. So hello, everyone, and let me tell you about the vision of interoperability that we have. As Peter mentioned, I'm Tomasz Drwięga. I'm a core developer at Parity. I've joined pretty early on. I was working on the Ethereum client first, and next switched to Substrate and Polkadot. And currently, I'm leading Parity's efforts in bridges. So what do I mean by interoperability? Let me explain it first. Let me draw an example here. It's a very oversimplified example, but I think it's there just to convey my point, and I think it will help you understand the rest of the presentation. So if we talk about interoperability in Web 2.0, you imagine a case where you want to insure yourself in case your flight gets delayed. So you buy an insurance, and then the insurer is able to actually fetch the flight delay data from the airline service. Then it's able to go to the airport server and fetch details about me arriving on time at the airport. And if both of these things happen, they can actually trigger a money transfer to my bank account by calling a bank service. And if we talk about blockchains currently, even though they are decentralized within, like if you look at the blockchain, it's actually decentralized. There's multiple nodes and the data is everywhere, but it's still a little bit siloed. So it's not able to interact with the same services as I drew in this example earlier. And it's because there is this very important property of a blockchain, which is its determinism. And what does it mean? It means I can take the entire history of a blockchain and I can verify the correctness of everything that happened in that chain. And I have to come up with exactly the same results at any point in time, even in a very distant future. And what it means is that to verify correctness, I can't rely on any external data, or I can't really cause any external side effects when I'm doing this verification. And this is a problem in blockchains currently. And we really need some kind of a way to interact with the external world, especially to drive user adoption of blockchains. For instance, we might want to get a weather forecast inside our blockchain so that our blockchain logic, a smart contract logic or a runtime logic, can access this data. Then we might also want to interact with the external world and write some data to Web 2.0, for instance. Storing data on-chain is really expensive. So instead of storing data, I might just store a hash and then use like Amazon AWS as free storage to hold the content for me. And how can we do that? Like, how can we fix this? So usually the solution here is, let's build oracles. Let's use these intermediaries that will act between the blockchain and the external world, and we'll be able to go and fetch this data that we want, and then bring this into this blockchain world as a form of a transaction. But the problem with intermediaries is, how do we make sure that they bring us the right data? We have no means to actually verify if the data is correct or not. And there are ways how we can reduce the trust that we have in these intermediaries. For instance, we might use some game theoretic or mechanism design mechanism that will lower the trust. Some data have something that is called a focal point. So for instance, if I ask someone, what's the temperature in Berlin at 10 a.m. on 1st December, it's it's easier for multiple intermediaries to actually give me the correct results than to coordinate a lie to fool me into thinking that the temperature was wrong, right? And we can obviously don't rely on a single intermediary, but put many of them and ask them the same question if there is this focal point. But for some interactions, we really need just a single intermediary to perform this action. Because if I want to send an email to a particular email address from my blockchain, then I can't really do that asking multiple intermediaries, because I want the recipient to receive exactly one copy of this email. And when we speak about interactions and data, it's not only Web 2.0 anymore. There is multiple blockchains out there, and each of them have wonderful utility that we might want to use. And connecting these blockchains will be really, really game-changing. So instead of like going back to this insurance example, instead of paying the amount in dollars, instead of doing a bank transfer, I can actually send Bitcoins to someone. And luckily, when we speak about interactions between blockchains, we can do a little bit better than simply employing intermediaries. We can do something that is called trustless interactions. Since the data that is on a blockchain, and since blockchain's usage of crypto primitives allows these interactions to be provable or verifiable. Just to give you an example of this, I've mentioned that you can store this data off-chain, right? And if I have a hash of this data on-chain and someone presents me the data itself, I can easily verify that the hash actually matches the data. So I can be 100% sure that the intermediary didn't really tamper with the data. And in this design, these intermediaries are usually called relayers or provers, because their task is to get some data to present it to the blockchain, and the blockchain can verify that this data is correct. And this significantly lowers the trust and allows us to build things like trustless bridges between blockchains or atomic swaps. And where does Polkadot fit into this this picture? So Polkadot is a protocol. It's like a framework for connecting these independent blockchains. Each of these blockchains can have completely different state transition function. So we call them heterogeneous because each of them have different properties. And Polkadot enables them to communicate through a messaging protocol called cross-chain messaging protocol, XCMP for short. And this is part of this framework. So we have this multiple independent blockchains speaking to each other and communicating with this first-class citizen called XCMP. And these blockchains are called parachains. If you've attended Rob's presentation, he was going into more details of parachains. The only thing I want to add on top of this is that not only they are interconnected, but they actually contribute and connect to the shared security pool for the entire ecosystem. And at Parity, we have built a framework to build blockchains. It's called Substrate. And actually, a reference implementation of this Polkadot protocol is built with Substrate itself. And then to help external developers build parachains that can be connected to the ecosystem, you can take a Cumulus library that you put on top of Substrate, and this enables you to easily build parachains that you later on can connect to the ecosystem. And the consequence of having chains be heterogeneous, it means that they can specialize into some unique features that they provide to the rest of the ecosystem. For instance, we might have chains, parachains, that are specialized in value transfers. So they reassemble Bitcoin. They might use the same protocol under the hood. They might use UTXO mechanisms. There might be chains that are optimized for generalized smart contracts execution. So they are very similar to Ethereum. And there might be different flavors of these parachains. We may have Ethereum virtual machine parachains, EVM parachains, but we may also have WebAssembly parachains that allow you to write smart contracts in WebAssembly, in, for instance, Parity's Inc. Language. And there might be chains that are optimized for privacy. So they provide privacy features for the entire ecosystem whenever someone in this ecosystem needs them. Secondly, Polkadot's design enable some of those parachains to act as bridges to existing independent blockchains. So it's and these blockchains doesn't necessarily have to be built with Substrate. Obviously, they can. You can build standalone blockchains with substrates and then bridge them to the ecosystem. But Polkadot's design doesn't prevent bridging to, for instance, Bitcoin or Ethereum. And when I talk bridges, I'm talking about fully trustless and permissionless bridges. And thirdly, to make it easy to build Oracle systems, Substrate comes with a built-in feature that allows you to write and to build and run an Oracle directly as part of your parachain or a standalone blockchain. So for instance, the thing that Chainlink does for Ethereum, this is something that can be built within Substrate-based blockchain currently. And as far as I know, Chainlink is actually using option workers for their Polkadot integration. So going back to this example of insurance application, right now you may imagine that this app kind of exists on the entire ecosystem at the same time. It runs on multiple chains at the same time. So instead of doing the bank transfer, we might use stablecoin, a parachain that provides us with stablecoin. For instance, we can use Akalas, USD, or we can use DAI through Ethereum Bridge. Then we can utilize this flight data. We can get this flight delay data from an Oracle parachain that exists in the ecosystem. To bridge the gap between the real world and blockchain, we might have an IoT parachain that will tell you, for instance, if I arrived at the airport on time. And it might do it in a private fashion, utilizing some privacy parachain as well. And then finally, you might have an insurance parachain that actually contains all the logic of this insurance execution. And it doesn't necessarily have to be a separate parachain. It might simply be a smart contract running on one of these smart contract execution environment parachains. And there is more. Every parachain that we deploy in the ecosystem might provide some additional services. I already mentioned this privacy as a service. So we have blockchains that are fully private right now, but usually this is an overkill. It might be enough to just have a small part of your process being private, and the rest might be public, because doing things privately obviously is expensive or comes with some trade-offs. Then we might bridge to non-public blockchains as well, which might provide services for the ecosystem. So imagine, I don't know, like government-backed identities that you can utilize in Polkadot ecosystem. Consortium chains may also tap into things that the Polkadot ecosystem provides. So they might need stablecoins for settlements. And like the kind of most obvious thing that people think about when they see interoperable blockchains is DeFi. So by bridging to Ethereum, we might directly get exposure to all of these ERC20 assets that live on Ethereum chain. We can even use DeFi building blocks as services from Ethereum. But knowing the obvious limitations of Ethereum, we may also build this DeFi blocks as part of the ecosystem directly as parachains, as some projects in our ecosystem are doing. So let me now tell you what we do to actually make this vision a reality. So Rob already mentioned parachains that are really close to be to be live. And we at the bridge team at Parity, we are working on building generic components that make it super easy to create these trustless bridges between multiple chains. Our main goal right now is to create tools to bridge to substrate-based chains. So it might be, for instance, to Polkadot-like networks, so two relay chains. We can bridge Polkadot and Kusama. Or we might bridge Polkadot to any standalone substrate chain that has its own consensus. And we are also working on optimizing bridging and working on extra protocols that make bridging more efficient or faster. Beefy is one of those examples. It's a protocol that is actually needed for us to bridge to Ethereum due to Ethereum's bandwidth limitation. Yeah, and going back to from like generic things to concrete things, our main focus right now at the bridges team is to run Kusama and Polkadot bridge, to bridge these two networks together. It means that every Kusama user will get access to, will be able to perform actions on Polkadot chain. For instance, it will be he will be able to spend dots on Polkadot chain, and vice versa. Every Polkadot user will be able to use anything that is available for Kusama users as well, only by interacting with Polkadot network. Next, we collaborate really closely with Snowfork, who is working on Ethereum and Polkadot bridge, and we also collaborate with Interlay, who is working on Bitcoin and Polkadot bridge. As I've mentioned earlier, the components that we are building are very generic, so we hope it's going to be really easy for us later on to bridge other chains that might be that the community will request us to bridge. And that would be all from my side. I guess we have some time for questions as well.
Thank you very much. Yeah, so there's a couple of questions in here. One is about describing how the Ethereum Polkadot bridge will work. So I think we want to save that one for Snowfork coming next. But one was what is meant by throughput by design for XCMP?
Throughput by design. Okay, I think this is a question that should rather go to Rob. I'm not sure I'm able to answer that correctly.
Got it. Okay. So maybe you can start to dig in a little bit to the second question on when Ethereum's bridge will be delivered, the transaction and operation on Ethereum via Polkadot. Will it be on-chain or off-chain? And could you describe a little bit of what the flow of what an Ethereum transaction will be via the Ethereum bridge?
Okay. Yeah, I forgot to mention that you should stay tuned for Aidan's and Alexei talk about Snowfork and Interlay efforts. And regarding Ethereum bridge, so this is a fully trustless bridge. It means that we have light clients of each side of other network deployed on chain. So it means that there is an Ethereum smart contract that is able to understand Polkadot consensus or parachain consensus, and vice versa. On a parachain, we have a frame palette that is able to understand Ethereum consensus. Mm-hmm. So first we focus on relaying headers from both of these networks to each other so that they are able to verify whatever happened on the other side of the bridge. Obviously, getting every header of a parachain or a relay chain to Ethereum side is not feasible due to gas costs. So we are working on this optimized protocol called Beefy that will allow us to lower the number of data that we actually have to take from the Polkadot side on the Ethereum side to make sure this verification is possible. And then when we have these light clients built, we can do this provable interactions that I've mentioned. So we can take a transaction or we can take an event that happened on Ethereum, and we can prove to Polkadot that this event actually happened, and Polkadot can make some action from this. So for instance, one of those actions might be you've made a ERC20 transfer to a special account that no one really has access to on Ethereum. And we consider, okay, oh yeah, it's going to be transferred to a smart contract. And that smart contract has this asset locked. And because it's locked, on Polkadot side, there's going to be a representation of this asset minted for you.
Yeah, and the key point here being, at least for the core bridges to the major other networks, Bitcoin, Ethereum, and others, we're focused heavily on building these fully trustless bridges, so non-custodial across the board. Thank you very much. Very enlightening conversation. And as you mentioned, definitely join for the Snow Fork and Interlay Polka BTC presentations coming up right after this, because we'll be going into these exact topics in much more depth. See you all over there in 1 minute.
Thank you.